Today, Lucas and I are going to take us through a little bit of API design. So a little bit about me, a little bit about Lucas, and then we'll go on about what we're going to do during this stream. So my name is Josh Ponelat. I run lead on the Swagger open source tooling. I work for a company called SmartBear that's custodian of those tools. I spend most of my days prioritizing work and digging at API stuff, but I would identify as a front-end engineer if someone were to push really, really hard, because I find myself comfortable with JSON and JavaScript and TypeScript stuff. Lucas, who are you?
Yeah, so my name is Lucas, and unlike you, if someone would have to ask, I would probably rather categorize myself as a backend engineer rather than a front-end engineer, because I'm more comfortable with writing backend. So this is what I do. I work independently. I have a little company of one, and I do different projects for different companies. Sometimes I do software development, as I said, mostly backend. And sometimes I do documentation projects, technical writing, and a little bit of consulting. And if you could think of APIs as run as a thread through my work. So most of my work is related to APIs in some ways. So
would you say APIs connect your work together?
Yeah, I think you could say that.
What we're going to be doing. So why are you interested in this stream? Well, API design, I think, is what we're going to be looking through. We're going to take a very expedited view of API design. It's something that should take a little more time than we're going to spend now. And on top of that, we're going to see how OpenAPI can act as a medium for API design. So API design can mean anything, could be you sitting on a beach just thinking about how to connect software together, or it can be OpenAPI, which is a little more formal and gives us a little more leverage in the world. And so we'll see how that connects up. To do so, we're going to look at a single product. So there's no particular reason why we picked this product to take a look at. We're going to look at Calendly.com. We'll walk through some of its features. And throughout that, we're going to be thinking about how would we build the API for this product. And we have sketched out and designed an API for this. It's definitely MVP stuff. So we've removed a lot of what would make a real product like Calendly successful and the complexities of its APIs, and focused more on some of the basic moving parts there. But the same principles apply and do scale quite a lot. So, you could use this to build Calendly's actual API design without a doubt. For those who don't know, Calendly.com is a cool little product, and it's trying to solve a scheduling problem. So we're in a very connected environment, global village, if you will. Everyone's on Zoom calls and we're talking across time zones. It can be very hard to organize a meeting time for two or more parties. So what Calendly does is there are two personas. So let's say I want to organize a coffee with Lucas, and I would then set up an event. I would provide my availability, and then I would give this URL to Lucas. And Lucas would then be able to take a look at my availability and find one that matches his availability. So we're solving a scheduling problem here. So we're going to look at that. We're going to look at those two workflows. So my persona, the event creator, and Lucas's persona, the event participant, maybe we can call it something like that. So we'll walk through the application, and we're going to keep in mind that we're interested in the API side of things. So we're not going to focus too much on the UI or how this product would do anything but be a vessel for an API. And when we say API, what I'm referring to here specifically is this browser application talking to some server, probably one server, even if it's a gateway connecting other servers together. So that connection there, how to send data to the server and how to receive data from the server, That's what I mean by API here. And even more specifically, RESTful or an HTTP API. So I don't even know if these folks use GraphQL. That would be really interesting and kind of not a bummer, but we can still design this API for REST. But that would kind of throw a spanner in the works, if you will. O flat JSON, OT flat J. I mean, this kind of looks RESTful-ish. I don't see like a single static hashes. Who knows? It kind of looks RESTfully. Sites data. Anyway, we're not going to cheat. We're not going to look at the network tabs. We're actually going to think of this as a design.
Yeah, we don't want to clone like technology wise. We just want to look at the product and then think of how we can build our own. And yeah, obviously like a very simplified version of their product.
Yeah. These guys have done a great job. We're not going to try to rebuild everything in a few minutes. So, okay, let's take a look at the first workflow, which is me. So I want to create a coffee event. You can see I've already added a title here, and we can update that in a second. So here's an event. There's two pieces of information or two categories of information I'm interested. But even before I'm starting to look at the details of it, the very first thing we have to notice is that we've fetched some details. So what event type is this? Coffee and, I don't know if you can see that, it's really small. Coffee and tea time. So I haven't written this in the browser yet. That means I must have fetched it from a server somewhere. So that's worth noting. So two categories of information. One is the metadata. So things like the event name, location, I guess, description, all of these things I like to group as sort of static or metadata for something. So let's change this name to coffee, tea, and biscuits. That's how you spell biscuits, right? Pretty sure about that. So that's some metadata. I'm not going to go through all the metadata. The second category of data that I'm really interested here is the availability. Let's switch. Why can I not click on it? Well, let me save and close. And then I can click on it. So what is my availability? When can I have coffee, tea, and biscuits with somebody else? So we can see the first thing here is duration. That's interesting. 15 custom. I'm going to say 45 minutes, I think, is a reasonable time for coffee and biscuits and tea. Set custom hours. So this is the meat. This is really interesting to me. This is the availability, and the way they've set it up is day of week plus some time ranges. So here we can see Sunday, Monday, Tuesday, and Wednesday already checked off. And Monday has 7 a.m. through 9 a.m. and 12 p.m. through 1 p.m. And you can add as many time ranges as you like. And it seems to like stack them by hour, which is also a pretty cool UI feature. And I think that's about the sum total of.
I think all the other options are like advanced features, and I think we can focus on just the metadata and the event times for this workflow.
Way more advanced than us humble API designers are interested. Well, contrived API designers at this point. So now that I've added and changed some data, I'm going to hit the save and close. And conceivably, what we're doing here is we're gathering the data on the form, putting it into some shape, and then sending it up to the server. So that if I refresh the page, when I fetch that data again, it's going to populate the browser with. So we named it coffee, tea, and biscuits, and that's now the current name there, coffee, tea, and biscuits. So to complete my flow, I've now completed my flow. I've created or set up an event that has my availability in it and some metadata. So what we would then do is this view live page and open up in a new tab. This is where Lucas's persona would kick in. So Lucas's persona is he wants to view my availability and choose one of those items, choose one of those slots. So it's a separate workflow because once I've done this and I then take that URL and put it in an email and send it out to Lucas, I walk away. I'm done. So that's a workflow more or less complete. So this is what Lucas's workflow would look like. So we got some metadata, which is pretty cool. We've got a duration, 45 minutes. And we have this cool widget that says what the availability is. So remember, we chose Monday, Tuesday, and Wednesday. So let's say Lucas feels like a Monday coffee. It seems our Monday slots are pretty early. That's fine, Lucas, right? So he's going to choose 7 o'clock.
Yeah,
and
totally fine.
Confirm some name, say Lucas with the lower U there, and then Lucas at example.com. Now, let's take a look at, just before we hit that confirm button, what did we do? Well, we fetched some data, this URL fetched some data from the server, and conceptually, it's the exact same data that we had set up earlier from our other workflow. So it's the same event data that I was modeling there that Lucas is now viewing, just in a very different format. So he's not interested in updating it. He just wants to see it that's most convenient for him to consume, which was to click on the calendar and find a slot. And then when I hit the schedule event, again, I'm sending the data that I've gathered on the form back to the server. What I'm doing there per se on a design level, I suppose schedule is one way we could say it, schedule an event. We're going to create a new term for it when we put on our RESTful hat, as in we want to design a RESTful service. So we'll take a look at that in a second. But to conclude our workflow, Lucas looked at the event data, chose some items, gathered some data, and then hit schedule event. Small fun fact, example.com, that domain name is dedicated to be used in examples. So if you're ever writing test code or using anything to do with an email address or a domain that you never want to actually an email to be sent to, example.com is a good bet. It's dedicated for that purpose. Even though I do know that Calendly does try to send an email to that email address at example.com, and I apologize, Calendly. I don't want to break your email servers there or get you in trouble. So we won't send too many of these. Okay, so now we can view this data. This can be related to our event, or it can be its own thing. From our design, we're going to think of this as its own thing. So it is an art form to decide what pieces of data belong together and which one should be considered separately. It's sort of like you would design a database. Does it belong inside one table, or should you break it out into multiple tables? Similarly with object-oriented design, is this one object, or should you break it down? And if we really want to be pedantic, functional programming has the same sets of problems, right? Do you want to define this as, I don't even know how, a type, I guess, would be a functional programming thing, or do you want to break it down? So in our case, we're going to look at the first workflow as working with one resource, and we'll get to what resource means. And then this is another workflow, and it's working with the original resource because it had to fetch it, and a new resource. It's now creating a schedule, or what we will call a reservation. So, okay, we sat down, we went through these flows, because remember, we're designing this API conceivably from scratch, or this system. And we sketched down these flows. Well, we need a place to capture this information. So I'm going to hop over to our whiteboard. This is scallydrawer.com. It's really fun. It creates these little diagrams, do smiley faces, etc. And we're going to sketch out our system. So the very first thing we did, workflow number one, we'll just say workflow number one, oops, and workflow number two. That's really small. I'll try to make it bigger now. And that face is terrifying, so I'm gonna get rid of it. Somehow dark. So workflow number one. Before we jump into this, what we're attempting to do now is domain modeling. So we're not on the API design yet. A domain is sort of creating a language and a system for the space that you want to operate in. So in Calendly.com's, in that example, we're thinking of scheduling events, we're thinking of people, we're thinking of coordinating, and we can assign names to and define this world. We're effectively creating a model version of the universe that's only interested in the things that we say should be interesting, like reservations. So something that would never go into this model of our universe would be, I don't know, how to bake a cake. It's unrelated, right? So in the baking cake universe, if you want to design a model around that, say you were building a recipe application or you were building an oven, that domain is different from our domain. So our domain is coordinating, scheduling, and things like that. And so domain modeling is the practice of bringing in concepts and relationships onto paper that captures your system. It's effectively sketching it out. And it can be very formal. Domain-driven development is its own practice. And there's UML and large, somewhat complicated ways of modeling your domain. Ours is very simple. We're going to stick with a whiteboard. And we're also going to do one other sort of cheat. We're not going to go through the full domain modeling process. We're going to skip over a few steps and think about the HTTP API that would result from this domain model. So if we were purists, we would do the domain model first and not think about the API side, just create the domain model. And then from that, we would see, okay, now we want to build a system out of this. What are the moving parts? Where are the services? Okay, there's a browser application, there's a server, and how do we design the API from this domain model?
And in our book, we did the whole domain modeling process. So we started by identifying concepts, write down a domain model without thinking about the API yet, and then talk about, okay, how can we map that domain model to an API that we want to design? So we'll just do a bit of a quicker version today, because in the book I think we use 2 chapters for it, and here we have just think like half an hour or so.
Half a chapter. We have half a chapter's worth of time.
Yeah.
Something like that. I don't know, a unit. But yeah, so we want to expedite this process, and you can think of it as layers, right? Layer 0 is a spark of an idea. And then a couple layers up, domain modeling, which is pretty low level, and then eventually API design. And right at the end, it's shipping your product or shipping your tool, getting support on that tool. And all of these layers, and this is why when folks say API design or design first, they're trying to move a lot of the problems you would encounter lower down on these layers. If you can solve a problem on paper before you have to refactor an entire code base, one might take a couple hours. Okay, this doesn't work on paper, let's try something else, versus refactoring a code base, which can take months, depending on its size and complexity. So it's cheaper to solve problems earlier on, which is why we want to take the due diligence of designing a domain model so we can figure out if there are problems there that we can avoid. And then designing an API, and then designing the stacks and writing the code and building frameworks, etc. So what was workflow 1? Well, we were an event scheduler. That was Josh, my persona. I wanted to organize some event and some metadata. So the first thing we did, and again, we're skipping over now to more or less API design aspects. The first thing we did is we loaded up the page, and we saw there was already existing data on there. So we needed to do a GET request. And we're going to start talking about HTTP semantics. So that would be their HTTP as a URL and a method, effectively. And we aren't going to go into too much detail around what those semantics are, but we're not going to go too deep anyway. on, we're going to cover get, put, and post. That's it. There's a lot of resources online, and yes, we do touch on it in the book too. So, okay, we're going to do a get request. We're going to say get, and what are we getting? Well, we're going to create this resource, this thing that we can do stuff with, and we're going to say it's an event. So the first thing we would do is get this event and mess around in the browser, and finally update the send it back to the server. And the best method for that in HTTP would be put. A put is a replace or an idempotent operation, if we want to be a little specific. So here we have our resource. Let's make our resource a little bigger. And then we have some stuff that we're doing to our resource. Effectively, that's what REST is. I think it's representational state transfer. Yeah, something like that. I always confuse it with resource state transfer, and I know supposed to know this, but it's not something I say every day, so I do get those things confused. Now that we've updated, so with this put, that's workflow 1. What's workflow 2? Well, it starts off with the same get event because it wants to present the event to Lukas so that he can take a look at the data inside. But at the end of his flow, I mean, we could copy that there just to be precise. At the end of his flow, he's going to create something new. He's going to create, and we're going to call it a reservation. Right? So he's going to reserve a slot. And when we think about resources or RESTful design, we're trying to put things into these boxes called resources so that we can use these verbs onto them. So in the difference between REST and something like RPC, remote procedure call, which is really just calling functions on the other side of a network, is that REST has some constraints. Think of putting things into boxes. If you can say, oh, I'm going to create something, I'm going to fetch something, and I'm going to update something. Try to put everything into those boxes that fits a noun, the thing. So we can get a reservation, we can create a reservation, we can update a reservation. The same applies for an event. It sounds very CRUD-like, and it kind of is. So we're going to have we want to do something with this reservation, we want to create a new one. And the best method for that, when we want to create new stuff, is a post. So this is not the most exciting diagram of a system. Like, I'd probably color it in a bit more, and we could look at what fields go into an event, what fields go into a reservation. We would sort of create relationships here, say, okay, well, these things are the same thing, obviously, so we don't have to duplicate that. And we could go on and add more and more details to our whiteboard that go into depth about what makes this API, right? Because we want to hand this over to developers to build. We want to say, here's an API. And there's many reasons why we would want to do that as a first step in any event. Like, why not just start coding straight away? And one good reason is, well, we could actually code in parallel. We could have a front-end developers and the back-end developers. Once they agree on the contract, they could work in parallel to get to the same goal. So designs are cool. And having designed an API like this, we could say, okay, our job is done. And remember, we could continue to add more and more detail and make this whiteboard huge and filled with stuff. But there's definitely some drawbacks to this approach. I wrote this whiteboard, and you're going to do it differently. Lukas is going to do it differently. And that means that every time someone new is going to look at this whiteboard, they have to figure out, what does Josh mean when he says reservation here? What are these squiggly lines? How is this? It's overwhelming, to be honest, right? So it would help if it were standardized. If I said, well, everything colored, underscored in a box is a method, an HTTP method. Everything with 2 squiggle lines is a noun or a URL, let's say, if we want to put slashes before these things to suddenly make it look like HTTP. And we could establish a standard. could say, well, when Josh puts a slash here, it's a URL. And so by putting some standards in place, we could move a little faster. You would understand and I would understand the same whiteboard. So what we're doing here is we're actually getting closer and closer to something that obviously exists and is the theme of this stream and this talk is OpenAPI. So as we've designed this, we've designed it, and that's true of whether we do an OpenAPI on a whiteboard. We've designed an API. It may not be as concrete as we like. We can certainly add those details, but the goal is to get to something a little more easy to understand. And once we've got that, we can start to share it. If we were to just standardize on how to write whiteboards, we would have moved onto level 1. But whiteboards also have a problem in that, well, for starters, they're images, right? So if we were to create this as a text document, we might get a whole new environment of or ecosystem of stuff we can use. And that's what OpenAPI is. It's hard to contain the excitement of getting to OpenAPI. Effectively, this is the too long to read version. If you put a little effort into creating the OpenAPI document, so it's a file, right? It's a text file. If you do that, you're effectively buying your ticket for this ecosystem of tooling that can consume that file. So what we've been talking about right now is just communicating. Hey, backend developer, Lucas, I want you to build me this API. That's a communication problem or a documentation problem. And that can be solved through OpenAPI, right? We could take the effort, design it there, and then I could hand it over. And there's a lot of details in there. But that's just level 1, right? It goes beyond that. What if we now want to generate code from that file? So Lucas doesn't want to do all the boilerplate of writing some server framework because they're mostly the same anyway. HTTP is not, radically different. It's pretty standard. So OpenAPI can act as the fuel for that. And there are tools like Swagger CodeGen, OpenAPI Generator that take those files and generate a whole bunch of languages or server stubs, server frameworks, or that use server frameworks, client SDKs, and other documentation. And it goes even beyond that. You can have OpenAPI integrated into your runtime. So when you receive a request body or a response body, you can, because you've defined it in OpenAPI, you can then validate to say, hey, this request body coming in, that doesn't look right. It's not JSON, or it's missing a field, and you can reject it. And you don't have to write that code by hand anymore. You can lean on OpenAPI and what it embeds in a JSON schema to do some of this stuff. So I had to blurt it all out. But what we're going to do now is we're going to take this whiteboard and we're going to create this OpenAPI file. We won't write the entire file in the session. We'll look at some sketches of it. And then I want to show you why I think it's cool and how we can generate some code from it.